Good morning, friends. We are in thermodynamic unit. In thermodynamic unit, last class what we discussed means we are discussed different types of systems. So today we are going to deal different parameters in the thermodynamics. So what are the thermodynamic parameters? Today our goal is we are concentrating on thermodynamic parameters. Thermodynamic parameters. So what does it mean by thermodynamic parameters? We already known are thermodynamic quantities, or we will get it as a thermodynamics quantities. So what does it mean? Thermodynamic parameters means or thermodynamic quantities means the quantities or parameters which can use to describe the state of the system. So the quantities or the parameters which are used to describe the state of the system. Those parameters are called the thermodynamic parameters, or those quantities are called the thermodynamics quantities. Generally what we use to describe the state of the system, examples, if we take the examples means, so describe the state of the system means, let me take, this is the system. In the thermodynamic topic, we feel that the thermodynamic system is a ideal gas. So it is the ideal gas which is having, or any gas is the system we will take. So as you know the definition of the system may can have the solid state or liquid state and gaseous state. Basically in our present unit we will feel that the system is gaseous state. So to explain the state of the system, what we need volume we need, or we need pressure of the system we need absolute temperature of the system we need it. Like that we need internal energy of the system we need it. Like this we need the entropy we needed, enthalpy we needed. Like this we need several parameters we needed. These parameters are called the thermodynamic parameters or thermodynamic quantities. Let me recall the definition. Quantities which are used to describe the state of the system, those quantities are called the thermodynamic quantities or thermodynamic parameters. Let me take the examples: volume, pressure, temperature, and internal energy, entropy, enthalpy, like that, Gibbs free energy, like that. So many parameters are there. Generally we will confine up to here only. These parameters are we will discuss more in detail about these quantities. Now the thermodynamic quantities are divided into two, they are classified in two groups. Let me go to the two groups of the thermodynamic quantities. The types of thermodynamic parameters are basically there are two types. One is the intensive properties or intensive parameters. First group is intensive properties, thermodynamics intensive properties. The other one is the extensive properties. Second group is the extensive properties. See, what we are discussing? We are discussing the thermodynamic properties, and we are classified the thermodynamic properties are two groups. One is the intensive properties, another one is the extensive properties. Now come to the intensive properties definition. if the thermodynamic parameters is independent of the extent of the system, that is it will independent of the mass of the system, that parameters is named as the intensive properties. Let me write the definition. The parameters, if the thermodynamic parameter is independent of mass of the system or size of the system or extent of the system, then those parameters are called as a intensive properties. So if you, that means let me take one small example. Let me take, this is the one system. This system size is I increase. Let me take, this is the bigger size of the system. So the mass is here and here is the different. Here is the mass is some value having the m1. Here is the mass of the system is m2. Here is the size of the system is size 1. Here is the size of the system is size 2. So here is the extension of the system. The boundaries of the system is smaller size. The boundaries of the system is increased. If some of the parameters are not varying, even though we are increasing the mass of the system, even though we are increasing the size of the system, even though we are increasing the we are extending the size of the system, so those parameters are called as a intensive properties or intensive parameters. Let me take the some of the examples of the system. So the pressure and absolute temperature or density or thermal conductivity, thermal conductivity, I will take some of the portion here. So thermal conductivity, or I am writing here the examples of the electrical potential, so viscosity and etc. There are some more examples are there. Let me concentrate here. So the parameters of the pressure, temperature, density, this is the rho is the density or thermal conductivity of the material, electric potential of the material, viscosity of the material, and some more examples are etc. I am taking. So these parameters are independent of the size of the system. Those so these properties or these parameters are called as a intensive properties of the system. Now come to the extensive properties of the system, means now if we take in this word, they will depend. In this one, independent, we will write it as the same definition. Do, that means the same definition we are writing. The word is dependent. So they will depend on the size of the system. So if the thermodynamic parameters are the thermodynamic parameters are dependent of mass of the system or size of the system or extent of the system, then those parameters are called as the extensive properties of the system. Let me take the examples for the extensive properties of the system. So extensive property of the system is internal and total energy of the system, total energy of the system, internal energy of the system, internal energy of the system, volume of the system, volume of the system. So let me take the entropy of the system, entropy of the system. So entropy of the system. Now if we take the enthalpy of the system like this, etc. So these parameters, let me take the size is increased, the volume will be increases. If the size is increases, the total internal energy will increases. So if the size is increases, total energy must be increases of the system. So the number of particles will increases. So the number of moles of the particles will also be increases. Those properties of the extensive properties. Now this is the broadly classified of the system. One more type of parameters are there, properties are there, that is the specific property of the system. The third category is specific properties of the system. So how we define this means, if the extensive properties are defined with unit mass, that the properties are named as a specific properties of the system. That means an extensive properties which are expressed in unit mass, expressed per unit mass, those properties are called as specific properties. An extensive properties which are expressed per unit mass, those properties are called as those are called as specific properties. That means, let me take one small example. So the specific volume is the extensive properties. So you know the volume is an extensive property. So if the volume is expressed per unit mass, that volume is named as specific volume. Specific volume is equal to volume of the system, total mass of the system, So this is called as the specific volume of the system. So these properties is named as the specific properties of the system. Now let me recall the system. Thermodynamic parameters means they are used for state of the system. To describe the state of the system, there are three types. One is the intensive properties, another one is the extensive properties, and third one is the specific properties. Intensive means they are independent to the size, mass, and boundary of the system. The extensive properties means they depends on size and mass of the system. Specific properties means the extensive properties are defined in per unit mass. So those properties are called the specific properties. Let me stop here. We will continue in the next lecture. Thank you.